lesson, we're going to continue our study of inverses and inverse functions by looking at the square root function. So where does the square root function come from? So if we look back to our knowledge of quadratic functions and understand the idea of inverses, that is where we're going to find where the square root function comes from. Now, if I specifically look at this equation y equals x squared and use what we have previously learned about inverses to find the inverse of this equation. So I'll do a quick swap of my x and y, and now I'll solve for y. So when I solve for y, we'll square root both sides. Now when I square root the y, we'll remember that we're going to have two choices for our answer. Now the idea when we have two choices for our answer for our square root, this is going to show us that the square root as an inverse will not actually be a function, and you're going to see why in a second. So what happens here is I actually get two functions out of this. I get the positive version of the square root of x, and I get the negative version of the square root of x. So what I'm going to do is I'm just going to plot a couple points. So I'm going to make an XY table, and I'm going to plug numbers in that I can easily square root. So if I start with 0, because I understand that what needs to be under the radical has to be a positive number so that I can square root and get a real value, not an imaginary solution, I know that my x has to be greater than or equal to 0, which is my radicand. So I'll plug 0 in, and the square root of 0 is 0. So what I'm going to do is I'm going to pick points that are easily square rooted. So I can easily square root 1, and the square root of 1 would be 1. I can input a 4, and the square root of 4 is 2. I can input a 9, and the square root of 9 is 3. So what I'm just doing is I'm placing in perfect squares into my square root function. So I have now 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9 is going to take me a little bit off my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to go up to 3. So you can see that I'm getting this curved function, but I'm only seeing part of it because I only graphed right now the positive of the square root of x. So now I'm going to come over here and look at the negative value of it. So again, I'm plotting values into x that I can square root. So I have to have, again, positive values. My radicand has to always be greater than or equal to 0. So I'll plug in a 0. Well, the square root of 0 is 0. The negative in front won't matter. The square root of 1 is 1. The negative in front will make that a negative 1. The square root of 4 is 2, and the negative will make that a negative 2. And then the square root of 9 will be a negative 3. So when I plot this on the graph, I would get 0, 0, 1, negative 1, 4, negative 2, and 9, negative 3. So I'm getting that slight curve again, but I'm getting the negative version of it. And you can see that if I would put these on to the same graph, that what I do get is that inverted parabola from the y equals x squared. If I would have graphed that original function of the parabola, and I'll sketch that very quickly here for you, you can see the actual rotation over that identity line, y equals x. But what happens is when we flip it and rotate it over that, you're going to get one positive square root of x and one negative square root of x. So if I actually drew a line through there, it would not pass the vertical line test. That's why we have to separate it into its positive version and its negative version to remain the functionality of the equation. All right, so let's go over some properties. First thing that I've mentioned when I graphed is that In order for a square root to be a real number, the radicand, that's that piece under the radical, cannot be negative. So when I go to graph these, the first thing I will always do is set the radicand greater than or equal to 0. Now, not only is that going to give me where my start will be located, it will also find the domain for me when I'm ready for that. So the first thing I do is set the radicand to be positive, greater than or equal to 0. Then we're going to solve that. So if I subtract 2, I see that my starting point is going to be at -2, and then I'm going to pick x values that are bigger from there. So I'll set my xy table up. Again, I'm going to start my xy table at -2, and then I'm going to get bigger from there. But if I plug in a -2 plus 2, that's going to start me at 0. Now I can go chronologically by 1. I can put -1 as my next point, or I can be smart and try to find my perfect squares. Now -1 will find my perfect square for me. So -1 plus 2 is a +1, and the square root of +1 is 1. All right, I'm going to go ahead and throw a 2 in next because I can see that 2 plus 2 is 4, and the square root of 4 is 2. I don't have to pick a perfect square. I can plug in 3 also. So I could do 3 plus 2 is 5. And I quickly do the square root of 5. And that will give me about 2.2 when I'm mapping that out. So I have 4 points. That's going to give me a nice curve on my graph. So I'm going to go ahead and graph these 4 points. So I'm going to start at -2. And my first point is at 0. -1 is at +1. 2 is going to go to +2, and you can see that it's starting to curve a little bit. 3 is going to be about 2.2, a little bit higher than the last point. So you can see that my graph is just shooting off in one direction. So looking at the properties here, my graph is starting at an x value of -2. So that's going to make my domain be all x values that are greater than or equal to -2. You can see that coming into play from here again. That's going to always set up my domain for me. Now my range is going in one direction too. So you're not going to see an all real values here in these square roots because you're always going to have a domain restriction, which is found here. Now my range here on the y-axis, you can see that my lowest y value here is 0. So my range are going to be all y values such that y is greater than or equal to 0. So it's starting at -2 on the x-axis, and it's starting at 0 on the y-axis. That will find our domain and range for us. Now if I take and analyze this graph, what it looked like compared to what the square root function looked like, which was here. If you remember back, let me kind of trace this again. This was just the square root of x, but when I graphed the square root of x plus 2, it actually moved back or to the left 2 spaces. Now, these translations are going to be the same as they were when we studied quadratic functions and we put our function in vertex form. So if I look at these variables again, now you'll remember we studied them in quadratics, so it looked like this. But instead of having the squared function, our function is the square root. Now those variables are going to do exactly what they did for quadratics. So the k on the outside is going to represent a vertical translation. That means if k is positive, it's going to move up. If k is negative, it's going to move down. Now the h on the inside of the function, remember that that was negative, so it always looks like it does the opposite. And if in front of h is negative, if that's a negative h in there, it's actually going to move that graph to the right. If it says positive h in there, it's going to move that graph, and I'm drawing it the wrong way, but it's going to move that graph to the left. And you can see back here, we had a +2 inside, So it moved our graph 2 units to the left. All right, and we have that A on the outside, so A is going to represent a stretch or a compress depending on the value of that A. If the absolute value of that A is greater than 1, so you're looking at 1.1 or 5 or 10 or 17, it's going to stretch that graph vertically. It's going to get taller. If that value of A is between 0 and 1, so you're looking at a fractional value, 3/4 or negative, or I'm sorry, 0.2, that's going to compress that graph vertically. So it's going to push it down closer to the axis. Now, if there is a negative on the outside, it's going to do what it always has done too, and it's going to flip that graph over the x-axis. So now let's look at some functions. Our first one is y equals 3 times the quantity of the square root of x minus 4 plus 2. So if I analyze this real quick, my starting point's going to go up 2 because of the plus 2. It's also going to move right 4 because of the minus 4. And this 3 is going to stretch it vertically. All right, so what does all that mean anyway? So I'm going to just graph it like I did the last one. I'm going to start with a radicand again. And that radicand, which is just x minus 4, has to be greater than or equal to 0. So I will solve that, and there's my start point. So I told you it was going to have to move to the right 4. There it is. So I'm going to set my table of values up. My first point I'm going to plot is 4. And if I plug a 4 in there, that's going to give me 0 times 3 plus 2. That's going to give me just a positive 2. And then I'm going to go ahead and pick my next point. I'm going to pick 5. So 5 minus 4 is 1. The square root of 1 is 1 times 3 plus 2 will also give me 5. Now again, you can go ahead and pick 6 here if you'd like. If you want to try to keep it perfect squares, then I'm going to go ahead and pick an 8 because I know 8 minus 4 gives me a perfect square of 4. The square root of 4 is 2 times 3 is 6 plus 2 is 8. And I'm going to do one more point. I like to do 4 points. It gives you a nice curve and shape to that. So 13 takes me back to 9. The square root of 9 is 3. Times 3 is 9 plus 2 is 11. So I've got my set of ordered pairs here, the start of my domain and the start of my range. So I'm going to go ahead and graph these. So I'm going to slide this over a little bit because I think I'm going to fall off my graph a little bit. I'll have 4, 2. This is going to be my first point. 5, 5. 1, 2, 3, 4, 5. 8 is going to take me a little bit off my graph, and it's going to go up a little bit higher, and 13 is going to take me out here even higher. So you can see that curve. You can see it's stretching. It's moved, my graph has moved to the right 4, 1, 2, 3, 4. It has moved up 2, 1, 2, and it has stretched taller than it normally would. If I'd go back and graph that original, that parent graph being the square root of x, I would have 0, 0, 1, 1, 4, 2. You can see it's a little bit flatter. So this graph is being stretched. And the domain of my new graph is going to start when x is 4, so when x is greater than or equal to 4. And my range is going to be when y is greater than or equal to 2. And I can find the domain and range very easily in my set of ordered pairs. So that's my square root function. All right, let's try another one just for practice. All right, again, I'm going to analyze some things. So this minus 6 says that I should move my graph down. This plus 5 tells me that I should move it to the left. And this negative is going to flip the x-axis. Now, again, I'm going to traditionally start under that radicand. I'm going to set that greater than or equal to 0. So my starting point of this graph is going to be at -5. So I'm going to go ahead and start my ordered pairs. And when I put in -5, that gives me a 0, and it's going to output me a -6. I'm going to go to the next value of -4. That's going to give me a 1 with a negative on the outside. -6 is going to take me to -7. And I'm going to throw in a -3. I know it's not a perfect square when I put that in there, but I'll show you it's okay that you don't always have to have perfect squares. So -3 plus 5 gives me 2. The square root of 2 is approximately 1.414. And I'll negate that, and then I'll subtract 7, and that's going to give me -7.414. And I'll go ahead and find my next perfect square, which is 4. 4 plus 5 is 9, and the square root of 9 is 3, so I have -3 minus 6 will give me -9. All right, so now I'm ready to graph that. So I'm going to plot my -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, -4, -4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. -3 is going to go to 7.414. And positive 4, 1, 2, 3, 4 is going to take me to -9. It's going to take me off that page over here. So you can see that this time my square root graph is being flipped because of that negative. So it did. It flipped over the axes, it moved to the left 5, and it moved down 6. So my domain of my function is going to be all values of x, such that x is greater than or equal to -5, except my range changes a little bit because of that negative, and my values are getting smaller. So my y values are y such that y is less than or equal to -6. So there's going to be a flip in my range because of that negative on the outside. All right, so now let's talk about it as a true inverse. So we're full circle to where we started with. So it says find the inverse of the function, but it only wants it when it's positive. And the reason for that is if I did the true function and I did the inverse, they would not be functions to one another. So I'm only looking at when x is greater than or equal to 0. Again, I'm going to go ahead and flip my x and my y. I'll go ahead and solve for my y. In solving, I'm going to have to square root both sides, but I'm only concerned with the positive values of x. So y is going to equal positive square root of x plus 1. That's what I'm going to look for. I'm going to start with my radicand, and my radicand tells me to start at -1. So I'll go ahead and plot some points again. So when I plug in -1 in there, it gives me 0. I'm going to plug in 0 in there, and it's going to give me 1. If I plug in 3, I can see 3 plus 1 is 4, and that's going to give me a positive square root of 2. Now it says to graph. Now we actually want to graph both pieces to this. So I'm going to start with the original function, which is x squared minus 1. Now if I remember from my quadratics, this is just a basic quadratic that's moved down 1. So a basic quadratic that moves down 1 starts at 0, 0. It goes out 1, up 1. It goes out 2, up 4, because we're squaring those terms. Except you'll recall that I only want the values that are greater than or equal to 0. So I'm going to ignore all of these negative pieces here. So this graph, or this part, is going to be my original function. Now I'm going to go ahead and graph the inverse, which is the square root of x plus 1. So that's going to give me up here -1, 0, 0, 1, 3, 2. And that's going to give me my inverse. And my graph is going to go right through there. And that's going to conclude my lesson. And my dog is speaking to all of you and telling you to have a wonderful day.